Hey everybody. So with this week's videos, what we're going to do is we're going to finish up solving quadratic equations with a couple of different strategies. So last videos we talked about factoring, we talked about graphing. Factoring should be something we should be somewhat familiar with, so hopefully that was okay. The graphing, using the technology to try to graph these things and then getting the points from that. So what I want to do today is just finish this off by talking about two other strategies that we can use. And again, they're strategies that we've talked about in the past, but I want to apply them to quadratic equations and look at some of the things that you can do with quadratic equations that you can't necessarily do with functions or expressions or things like that. So at this point, we've discussed solving quadratic equations by factoring. So another method that we could be using is completing the square. So we've talked about completing the square before, and we've talked about the process in which we do that, factoring out the a from the first two terms, and then looking at that b number and halving it and squaring it, and then adding and subtracting, right? So some of that should sound familiar. If you don't quite remember, I will give you a little refresher while we go through these notes. So let's consider this one right here. So this quadratic equation, kind of a mess, right? There's fractions, there's a negative here, right? It's kind of a messy thing to work with. So let's consider this one here, and let's try to use completing the square to solve this one. Now, why would I use completing the square? Well, first off, this thing can't be factored. You can't factor this thing. So if it can't be factored, we have to find some other strategy. So if we didn't have access to our technology to graph it, and we aren't able to factor it, well, then we have to pick a different strategy. And we're going to look at two of those today. We're going to look at completing the square first, and then we're going to look at using the quadratic formula. So to solve this one, we would have to use completing the square. So this is not able to be factored, so we complete the square to put it into vertex form, right? And then once it's in vertex form, we can solve for x. So how are we going to do that? So what I would suggest is let's make our lives a little bit easier. So negative 1 over 5 x squared plus 2x plus 1 over 20, right, is equal to 0. So again, the nice thing about these types of questions is a lot of students don't like fractions. Well, when you're working with an equation, we can kind of circumvent some of the things we aren't able to do when we're working with an expression or a function. For example, if I were to say just factor this expression that didn't have the equal 0, just this part right here, right? You can't use inverse operations. We can't get rid of either side or anything because there's no equals to sign to get rid of, nothing to balance it out. But because I have this equals 0, what I can do is I can multiply or divide both sides by any constant I want. And what's going to happen is my left-hand side will change accordingly. My right-hand side, because it's already 0, will just stay 0. So what I can do here is I can take both sides of my equation and multiply them by 20. And the reason I'm picking 20 here is because if I multiply, actually, I'm going to multiply by negative 20. If I multiply negative 1 over 5 by 20, I'm going to get a whole number. And if I multiply 1 over 20 by negative 20, again, I'm going to get a whole number. If I do that, I get positive 4x squared minus 40x minus 1. Right? So again, all that does is it makes our lives a little bit easier because now we don't have to work with those fractions anymore. So now let's go through the process of completing the square. So just follow along. If you remember how to complete the square, great. If you don't, just pay attention to what I'm doing and let's do it. So first step, we want to take the a value and factor it out of the first two terms. So we're going to take this 4 and we're going to remove it from the x squared term. So 4 divided by 4 is 1. And we're going to remove it from the x term. So 40 divided by 4 is 10. And then close our bracket, and we still have that minus 1 on the end. So that thing's going to be equal to 0, right? And then we look at the b, that number that's left over inside my bracket here, right? This 10, and we're going to half it and square it, right? So we're going to say 10, and if we half 10, we get 5, negative, negative 5. And then if we take negative 5 and we square it, we get 25, right? So sometimes in class I'll use the phrase half square plus minus because that's kind of the next two steps combined, right? We take that negative 10, we half it, we get negative 5. We square that answer, we get 25. And then what we're going to do with that 25 is we're going to both add it So x squared minus 10x plus 25, and we're going to subtract it, right? And the reason that we have to subtract it is we add this 25, we change the value of my left-hand side, and it's no longer going to be equal to 0. So in order to make up for that, we also have to subtract 25. Now, again, you might be asking, well, why did we add the 25 in the first place? And the reason being is if you think about perfect square trinomials, the ax squared plus 2abx plus b squared, right? This is a perfect square trinomial. Well, this right here, these first three terms, follow that pattern, right? 1 squared is 1, x squared is x squared, right? My x is this x here. My b squared is 25, right? So we're following that pattern. So now what we're going to do is we're going to take this negative 25 and move it outside of my bracket by multiplying the in front of the bracket over the 4. So I get 4x squared minus 10x plus 25 minus 25 times 4, which is 100. And then what I'm going to do is factor my trinomial, factor this perfect square. So we get 4x minus 5, right? And that's how we factor perfect square trinomial. What happens here is we get ax plus b squared. So in this case, if a is 1 and b is 5, right, that's where these are coming from, this 1x and this negative 5. We're going to combine these two terms, so negative 101, and that's still equal to 0. Now what we can do is, because we have this thing in vertex form, we can now get the x by itself, right? If it was just a standard form where you have ax squared plus bx plus c, right? So ax squared plus bx plus c, it's hard to get x by itself here because there's two x. There's this x squared, but there's also this x here. They can't be combined because they're not like terms, but we're trying to solve for x. So because there's two instances of x there, it's going to make it a lot harder to try and solve for x. But with our vertex form, we only have the 1x. It's right here. So all I need to do now is use my inverse operations to get this x by itself. So let's move the 101 to the other side by adding it. So I get 4x minus 5 squared is equal to 101. Then get rid of the 4 by dividing it. So x minus 5 squared is equal to 101 over 4. Then get rid of that square by taking the square root of both sides. So if I take the square root of the left side, they cancel out. I'm just left with x minus 5. And then if I take the square root of the right side, I get the square root of 101 over 4. Now, again, we have to be careful. Whenever we're taking the square root, when we're trying to do these inverse operations, we have to not just consider what is the square root of 101 over 4, but we have to consider what answer that if I squared it would give me 101 over 4. And there's two answers there. There's the positive 101 over 4, but also the negative 101 over 4, because if I take a negative number and square it, I get a positive answer. Now, finally, I add 5 to both sides, and I get x is equal to, I'm going to put the positive 5 in front of it, plus or minus the square root of 101, and I can do the square root of 4 and get 2. And this would be my answer. This is the most accurate answer I can have. If you're looking to use decimals, what you can do is plug this into your calculator and round off to so many decimal places, but this is the most accurate answer I can have, where the 5 is my middle, and then my 101.2 is going to be on either side of that, right? We're going to add it, the root 101 over 2, and then we're going to subtract root 101 over 2 to get my two answers for x. Okay? So how do we use that? Well, what we can do is we're using this strategy just the same way we would have used factoring, or just the same way we would have used graphing, or just the same way we're going to use the quadratic formula. The plan is take a quadratic, set it equal to 0, then use one of the strategies we've talked about, right? So here's another one. So we have a word problem here. So again, taking these ideas and trying to it with our idea of what a quadratic will work, right? So here's my question. A widescreen television has a diagonal measure of 42 inches, right? So the diagonal is how we measure televisions. So that's from corner to corner. So from corner to corner, 42 inches. The width of the screen is 16 inches more than the height. So the width and the height. Determine the dimensions of the screen to the nearest tenth of an inch. So this is the issue we have here, right? If I wanted to find my dimensions, the problem we have is we have two variables here. We have W's and we have H's. So what I need to do is I need to rewrite one of my variables in terms of the other. So what do I know? Well, I know the width is 16 inches more than the height. So what I can do is I can get rid of this W, and in its place I can say, well, I know W is 16 inches more than H, so let's write an expression that says that. W is equal to H plus 16. So now that I have two side lengths that both have the same variable, we need to figure out an equation or some formula that will tie all three of these terms together. Now, what shape is this that uses these three sides? It's a right angle triangle. So what formula do we have that allows us to connect all three sides of the right angle triangle? It's our Pythagorean theorem. A squared plus b squared is equal to c squared. Or in other terms, if I make my HA, so we have H squared plus my width is B, so instead of writing W, we can write H plus 16 squared is equal to 42 squared. So now, when I expand this thing, I'm going to have a quadratic formula or a quadratic equation. So let's say H squared plus, we would use FOIL in order to expand this thing, right? It's H plus 16 times H plus 16. So H squared plus 32H plus 16 squared would be 160, 196. Nope, that's not right. 256, sorry, right? And then that is going to be equal to 42 squared. So 40 times 40, 1600 plus 80 plus 80, so 1760 plus 4 is 1764. Right. So now what we need to do is get everything to one side and treat it just like a quadratic equation, right? So what I need to do is, sorry, get everything to one side, right? And then use one of our strategies. So we're going to stick with the completing the square that we've been doing. I'm just grabbing my calculator here so I can check my work. So 42 squared, 1764, perfect. So combine like terms. So h squared plus h squared is 2h squared. 32h is the only term, so 32h. And then if I take this 1764 and I move it to the right-hand side, I'm going to subtract it. So 256 minus 1764 is negative 1508, and that's going to be equal to 0. Right? So now what I need to do is complete the square, right? So I'm going to take the 2 and factor it out of the first two terms. So 2h squared plus 16h minus 1508 will be equal to 0, right? Take that middle term, half square plus minus, right? So 2h squared plus 16h, so half of 16 is 8, and 8 squared is 64, so we'll add 64, and we'll subtract 64 minus 1508, right? And then we're going to take the minus 64 out of the bracket by multiplying it by 2, so 2h squared plus 16h plus 64 minus 128 minus 1508 is equal to 0, right? And then finally we are going to complete the square. So 2 and then h plus 8 squared minus, so if I take those and I add them together, I get 1636. So this thing will be equal to 0. So now we need to solve for h by doing our inverse operation, right? So we're going to add 1636 to both sides, right? 2h plus 8 squared is equal to 1636, and then divide both sides by 2 is equal to 818, and then take the square root of both sides. So take the square root of both sides, and we get h plus 8 is equal to the positive and the negative of 818. Let's see if 818 can be simplified at all. Look like it. So then I'm going to subtract 8 from both sides. So negative 8 plus or minus the square root of 818. Now, this might not mean much if you were going to go to the store and buy a TV and you were looking for specific dimensions, right? Using this terminology really probably doesn't make much sense. But what we can do is we can start rounding, right? So if I take the square root of 818, so if I take the square root of 818, I get approximately, so the square root of 818 is approximately 28.6. So what that means is the height of my television is going to be equal to negative 8 plus or minus 28.6. So if I do the subtraction, so if I take that answer and I subtract 8, or sorry, so I take the negative 8 and I subtract my 28.6, I get a height of negative 36.6. Or if I add 8, I get a height of 20.6. Now, in terms of what makes the most sense, right, the height being a positive number is what makes the most sense in this context. So my height is 20.6 inches. And then again, if we go back to the question, we know television is 16 units more than the height. So my width is 16 units more than the 20.6, or 36.6 inches. Okay, so completing the square has a purpose, and the main purpose to completing the square is the fact that it's where we get the quadratic formula from. So there's all kinds of questions that we could be doing, word problems, um, other examples where we're rearranging and finding an answer, lots of things like that, right? So all types of these questions that we could be doing. I'm not going to spend too much time going over these questions. You're welcome to try them yourself and then come to our live session Thursday and ask questions. So here's one here that you can try. If you want to pause the video, give it a try. Right, here's another one, another example, and then some practice. So again, if you want to try, go ahead. Right. Here's one when a isn't 1. Right, so all kinds of these questions that you can try. I'm just not going to take the time to go through them one after another, after another, after another. If you guys want to see them done, come to the live session Thursday. I'll go over these questions. I'll go over the questions from the assignment as well. But what I would like to do is look at the quadratic formula, because the quadratic formula, in my opinion, is um, it's more useful, right? It's more useful because it takes this act of completing the square and it gives you kind of the end result. And we've talked about this in class. We've talked about how you can take the quadratic formula in or quadratic equation in standard form, complete the square, solve for x, and it gives you this thing where the a's, b's, and c's fill into this formula nicely, right? So instead of using the completing the square over and over and over, we've simplified it into this one nice formula. So let's take a look at some of these questions. So for example, if I wanted to solve this one here, again, what I can do is I can plug this number, plug A, B, and C into my quadratic formula. And here's the thing that a lot of students have a hard time with. When you're factoring, right, when you're factoring a quadratic equation, so for example, if I had x squared plus 5x plus 6, and that thing is equal to 0. So to factor this, we get x plus 2 and x plus 3 is equal to 0. And a lot of the time, students are like, okay, well, that means x is negative 2, right? And negative 3. Great, awesome. But then we don't understand necessarily what that means because this is the answer. This is the value for x that's going to make that quadratic equation equal 0. If I were to take a negative 2 and plug it into this equation, I'm going to get 0. If I were to take a negative 3 and plug it into this equation, I'm going to get 0. With this quadratic formula, it is also going to spit out two answers. It's going to give you two numbers. But the thing that I find students mix up a lot is here we have to change the sign because we're looking for a number of x that's going to make this bracket 0. So this x plus 2 tells us the answer is going to be negative 2. When I use the quadratic formula, I don't have to change the sign. This formula tells me x will be equal to whatever number I get. So whatever number you get from the quadratic formula, that is your answer. There is no sign changing involved. So if I take my numbers here, so x is going to be equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So now it's just a matter of using my order of operations, right? Start simplifying all these terms. So x is going to be equal to negative 5 plus or minus the square root of 5 squared is 25. 4 times 3 times 2 is 24. But it's going to be plus 24 because I have one negative here and another negative there. And a negative times a negative gives me a positive. All over 2 times 3, which is 6. So I get x is equal to negative 5 plus or minus the square root of 49 all over 6, which is negative 5 plus or minus the square root, not the square root of 49, is 7 over 6. So now if I do those two answers, if I take x or negative 5 and I add 7, so x is going to be equal to negative 5 plus 7 over 6, or x is going to be equal to negative 5 minus 7 over 6, those are going to be my two answers. So negative 5 plus 7 is 2, 2 over 6, and simplify that, I get 1 over 3. Negative 5 minus 7 is negative 12 over 6, and if I simplify that, I get negative 2. So there are my two possible answers. And again, we don't change the sign because what this formula does is it gives us the answers with the sign. Okay. So the interesting thing about the quadratic formula is it has this part of it that is underneath a square root, right? If you look back at the quadratic formula, there is this section and it's underneath a square root symbol. So just consider that for a second. Is it possible for us to take the square root of any number? Right? So just consider that question for a second while we go over this next page. So if you look at the quadratic formula, you'll notice that there is a square root term in it. So the term underneath the square root is what we call the discriminant. Okay? And what the discriminant will tell us is it will tell us how many possible answers we're going to have. So the part that's underneath the square root is just this little section here, b squared minus 4ac, and that thing we call the discriminant. So we use this term to determine the nature of the roots of a quadratic equation. And what I mean by the nature of the roots is how many roots are there? Because if you think about a parabola, when we go to take these quadratics and graph their functions, a parabola has that U shape to it, right? It looks something like this, or it could be upside down and be that N shape. So since it doesn't necessarily go down forever, up forever, right? It has this vertex, this highest or lowest point. Depending on where that vertex is, will actually change our number of roots. So there are a possibility of three different types of discriminants. We have discriminants that are greater than 0, right? So for example, if I had a discriminant that's positive, it's going to give me a positive answer. We have a discriminant that is equal to 0, and we have a discriminant that is less than 0. So what does that mean? Well, a discriminant that is greater than 0, if I were to take my quadratic equation, so my x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If my discriminant is greater than 0, what that means is that this square root will have an answer. It might be huge, it might be small, it might be somewhere in between, but there will be an answer to this square root. So if the discriminant is positive, then when we take the square root, we are going to get some value. This means that we are going to have two real roots. Okay, so when I talk about the nature of the roots, this statement right here, the two real roots, that's what I'm talking about. Two real and distinct roots. Because when you take this square root and you find a value here, you're going to add it to negative b and you're going to subtract it from negative b, and that's what's going to get you your two answers. So it means graphically what that means is we're going to have two x-intercepts. Now, if my discriminant is equal to 0, right? If the discriminant is equal to 0, what's going to end up happening is that square root is going to go away, right? Because if we take something, we take the square root of 0, we still get 0. Whether I add 0 to negative b or I subtract 0 to negative b, I'm still going to get negative b. So I only have one root. But again, this nature of quadratics, there's always two roots, but what it means is that we have the root where we add 0, and then we have the root where we subtract 0. But what ends up happening is we get one answer, so we have two real roots, it's just that they're both equal to each other. Graphically, what this means is that my parabola just touches my x-intercept and then bounces off. There's only one x-intercept, and it's right on that x-axis. And then finally, when my discriminant is negative, when it's less than 0, well, what happens when we try to take the square root of a negative number? So for example, if I want to take the square root of negative 16, right, really quickly, you might say that that's equal to negative 4. But if I go backwards, if I take negative 4 and I square it, does that get me back to negative 16? And the answer is no. Negative 4 squared is equal to positive 16. So we can't take the square root of a negative number. So with that in mind, if this is the case, we would be forced to take the square root of a negative number. Since that is not possible, we see that there are no real roots. And again, graphically, what that means is that my parabola never passes through the x-axis. There are no x-intercepts, so it could be above the x-axis going up, or it could be below the x-axis going down, but it never passes through the x-axis. So why do we care about the discriminant? Well, the nice thing about the discriminant is if I'm working with one of these questions where I want to find the answer, it could very well be that there is no answer, or there could be one answer, or there could be two answers. But if there's no answer, then it's not really worth my time going through the question just to figure out that there's no answer. So what we want to do is things like this, where we're going to use the discriminant to help determine the nature of each of these quadratics. So for question A here, we get negative 2x squared plus 3x plus 8. What we're going to do is we're going to check the discriminant. So the discriminant is going to be equal to b squared, b squared, so 3 squared minus 4ac. So now, right away, start recognizing that there's certain patterns here, right? If A or C is negative, but not both of them, we're going to get a negative 4 times a negative number, which is going to end up leaving us with a positive. So remember, there's three types of discriminants. There's discriminants when it's positive, when it's 0, when it's negative. It doesn't really matter. If I'm just talking about the nature of the roots, it doesn't matter the actual value of the discriminants. All that really matters is whether it's positive or negative. So right away, for question A, what I know is that my discriminant is going to be greater than 0. And really, at the end of the day, that's all I care about because that's going to tell me how many roots. So for question A, I have two real distinct, right, because they're both different roots. Now, if you're not convinced, what you can do is you could do this out. So 3 squared is 9, and negative 4 times negative 2 is positive 8, and positive 8 times 8 is positive 64, which is equal to positive 73, and that is, in fact, greater than 0. So what that means is for part A, or question A here, I have two real distinct roots. Okay, for question B, do the same thing. So use my discriminant. So b squared So now, just be careful here. What we want to make sure is that when we're using the A's, B's, and C's, that we're using it on a quadratic that's in standard form. So this minus 9 over here needs to come over to the left-hand side first in order for this to work. So plus 9, right? And then set that equal to 0. So now we're going to look at our discriminant and say the discriminant is going to be equal to b squared minus 4ac. So again, with this one, we can check and say, okay, well, what's going to happen here? And again, right away, I'm seeing that this thing's probably going to be negative, but let's check. So negative 5 squared is 25. And then 4 times 3 is 12, and 12 times 9 is 108. So 25 take away 108 is negative 83. So again, because my discriminant is negative, if I were to take the square root of this in my quadratic formula, I get an error. So what that means is I have no real roots. There's no real roots. And finally, question C. So again, take my discriminant and say b squared minus 4ac is equal to, so negative 3 squared is 9, and 1/4 of 4 is 1, and 1 times 9 is 9, and that's going to be equal to 0. So this time the discriminant is equal to 0. So again, what that means is I will have 2 real. So again, they are real, and there are 2 of them. It's just that they are equal. 2 real equal roots, where they're both going to be, we don't know the value of them, but they will be the same value. Okay? So what we can do with these types of questions is now that I know, I can check my discriminant first, then go back and say, okay, well, here's what my answer is going to be, right? So again, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you might think, well, why am I doing the extra work of checking the discriminant if I can just plug the numbers into my equation and get the answer anyway? It isn't extra work, because the nice thing is I could rewrite this formula and say x is equal to negative b plus or minus the square root of my discriminant over 2a. So if you do the work to find the discriminant and then you find, yeah, there is an answer or there's 2 answers, then I don't have to worry about redoing this step. I've already done my b squared minus 4ac. So I can just take that answer and plug it into my equation and then keep going from there. So for example, so maybe you guys want to try this. So maybe at this point, pause the video and try to solve for x for these 3 equations. Once you're ready, restart it and we'll go. So again, what we're going to do here is we're going to say x is equal to, so I'm sorry, I'm going to check my discriminant first. So I'll find my discriminant by doing b squared minus 4ac, which is 25, minus 16, which is 9. So then it is positive, it's greater than 0, so there's going to be 2 answers. So then from here, I can say x is equal to negative b plus or minus the square root of 9, right? So that discriminant, that answer that I found, goes into my equation under my square root, and then 2a. So then the negative 5 is positive 5 plus or minus the square root of 9 is 3 over 2. So I get 2 answers. I get 5 plus 3 is 8, divided by 2 is 4, and I get 5 minus 3, which is 2, divided by 2 is 1. So I get 2 possible answers here when x is 4 and when x is 1. Okay, let's take a look at letter B now. The discriminant is going to be equal to b squared minus 4ac. So 4 squared is 16 minus 3. This 3 and this 3 will cancel. So 4 times 4 is 16, which is 0. Right? So again, the nice thing is the discriminant is equal to 0. So all I really get is x is going to be equal to negative b over 2a. Right? So negative b over 2a, plug my numbers in, so negative 4 over 2 times 3, or negative 4 over 6, which simplifies to negative 2 over 3. And then lastly, so again with these types of questions, make sure that it's equal to 0, so 2x squared minus 8x plus 9 is equal to 0. Then find my discriminant, so it's going to be b squared minus 4ac, which is 64 minus 72, and that is -8. So again, the nice thing about this is now that I know my discriminant is negative, I'm not going to do any more work. This one has no, I guess right down here, no real roots. And that's it. I don't need to do any more work for this question because there isn't going to be an answer. Okay. So, I mean, we'll stop there. Again, what I would suggest is if you guys want some more practice, feel free to try these questions yourselves, and then come to class Thursday with questions if you still have them, because we have been doing these things. We have been doing completing the square. We have been doing the quadratic formula. So I don't want to spend too much more time focusing on these. So if you want to practice them, try these questions, right? Try this question, then go back to the assignment that I posted from last week, and you should be able to do every other question on there. But before I call it a day, I do want to look at one more slide here. So picking a strategy. So when it comes to these quadratic equations, and you're being asked to solve, right? You're being asked to find the answer. We really have to try and pick some kind of strategy, right? Because depending on the question, it might be easier to do it one way versus another. So to pick a strategy, now that we have discussed all four methods, so our four methods again are graphing using some kind of electronic device, factoring, quadratic formula, completing the square. Unless you are specifically told use this strategy, it is an important skill to be able to pick the one that suits the situation the best. So this is the order that I choose to work in. It might be different for you, but I just find that these strategies go from fastest to slowest. Okay, strategy one is to factor. Then if I can't factor, I'm going to graph it or use the quadratic formula, right? If I have an electronic device that can graph it for me, great. I can plug it in, find my zeros. If I don't, then I'll use my quadratic formula. Then finally, I'm going to complete the square. The only time I ever really complete the square is if the question is telling me to. If it's saying you need to do this by doing complete the square, right? Because we've already gone through the process of getting the quadratic formula by completing the square, so why go through that extra work? Okay, so of course it is always up to you which method you prefer, unless you are told to do a specific one. So what I'll leave you with today is to try this question here by doing all four strategies and then seeing which one makes the most sense for you. What I would suggest is trying to factor first, because that is the quickest strategy. And if you get good at factoring, these questions become a lot easier. Okay, we'll call it there. Again, if you guys have any questions, come to class Thursday. Come to the live session Thursday with your questions, and have a great day.